Welcome to our August trio talk. We have performance and model optimization with Jack Caron, Kelvin Ip, and Pascal Opry. I will hand you over to their very capable presentation.
Awesome. Thank you very much, Amanda. I'll just take over and I'll start sharing screen. Sound good?
Sounds great.
Let me just share here. Can everyone see my screen okay?
Yes.
Okay, perfect. So let's just hop right into it. Yeah, so thank you everyone for joining us today. We're going to be talking a little bit about performance and model optimizations in 3Kit and what you can do today to get the most out of your models that you've already imported or outside of it. But before we get into the nitty-gritty of it, I'd like to take a moment to introduce the speakers for today. So my name is Kelvin Ip. I'm a 3D product manager. And Pascal and Jack, if you want to introduce yourselves.
Hi, I'm Pascal, senior 3D artist at 3Kit.
And I'm Jack, senior 3D developer, and probably the one that made implemented most of the feature that we see today.
Absolutely. Awesome. Thanks. Yeah, so that's a little bit of who we are, and I'd then like to move on to agenda. So the things that we're going to be covering today, I'd like this to be a more interactive session and not just us going over slides. We want to show off some things in the platform, some things outside of the platform, and make it as interactive as possible. That being said, if there's any questions at any point, just raise your hand and we'll address questions as we go. But the agenda for today is we're going to first take a look at what you can do outside of 3Kit, even before importing any assets, some of the things that you could do to get the most performance and optimization out of your assets. And then we're moving into 3Kit. We're going to be talking about quantization and simplification, and then texture optimization and augmented reality optimization. And at the end, I'd like to leave maybe 10-15 minutes for any questions that we didn't get to during these parts. But yeah, that's kind of the agenda for today. And with that, I'll let Pascal take over and take it off to modeling best practices.
All right. Let's go to the, all right. It's always a good thing to, like, before starting any of your project, to like think of like what's going to be necessary, and always like looking into like seeing if you can remove any unnecessary object, like something like could be like rivets behind like a sofa, or it could be like a cabinet and from your AutoCADs where you have like all your you have like your hooks or something that you're never going to see over on your on the platform and on the player. So it's always a good thing to remove things that you will never see to help increasing your performance play on the player. It's always to keep also your polygon and your number of meshes that you that is going to be loading, to keep the file size as small as possible. Another thing is sometimes some files that you receive can be very dense, with lots of faces. It could be from CAD files that is very complex. So it's always good to like, if the project allows you to like keep and then retopologizing your model by reducing the faces on some of your models. You can see here on the sofa, like where the original left cushion was pretty dense, and then you can see on the right where it was a little bit more some face were removed to keep it more simple, and you can also get the same result from what it looks like, what as for like visualizations, how you keep it it would look the same. So it also helps increasing performance on the player. Also could help also for your 3D artists as they work on the main product on your model. It will help them for texturing, and it's a little bit easier to also UV unwrap, because you get less faces, and it makes it less complicated. Another good thing is looking at the model like this here on this for the sofa, is if each cushions are sharing the same type of materials, you want to see if you can combine those models, those meshes, into one big big model. Let's see, like all the cushions on the side, and so this way it will be only one draw call to call for one material to apply to the entire sofa, versus each cushions to be separated, and every time it loads it has to call for the same material multiple times. So it's always good to like look into your model, see if you can combine. It also makes it easier once it's on 3Kit. You can see now on this model you will only have 2 mesh. It could be the legs, because they won't be sharing like a leather materials, and then the main sofa will have its own material. And then you also have to think also about AR supports if your project will be going towards some AR, that there's some special limitations where you have to take in considerations your UV map, making sure you're like in the one-on-one 0 to 1, making sure all your UV map is centered, and there's also the shadow, making sure that you won't need the shadow because there's some limitations there. And 3Kit also works with a Rapid Compact, which is a third-party company where they help taking your high res, your very high polygon asset, and they have an automation service where they would bring some lower polygon lower polygon models to your product. And then if sometimes like this is some models, like we have like this new feature where Kelvin will be talking about, that will be helping also to address some of these model reduction, but they're also directly on 3Kit.
Awesome. Thank you, Pascal. Yeah, so that was everything outside of 3Kit before you move your models in. I'm going to be talking a little bit about, once you're inside the platform, some of the features that we offer that you can take advantage of today to get the most performance out of your models. Meshes, materials. So the first thing that I want to talk about, and some of you probably already used but may not know about, is quantization. So when you upload any mesh assets to 3Kit, quantization is automatically applied to it. This is something you can turn off, but generally you wouldn't want to. And it processes the way the data is stored, giving you an immediate performance boost by compressing the data of the meshes. And although the amount of saving does vary depending on the complexity of the model, you could expect a 20 to 45% original size reduction when you actually load the mesh. So that translates into direct savings that you're going to get when the user or whoever is working on the project starts to implement. I see that there's a chat message here. Oh, never mind. All good. Yeah, so with that in mind, quantization, I'd like to show you a little bit of an example, kind of walk you through the platform, what it is, where you can find it, and how you'd go about taking advantage of it, although it is already applied automatically. So let me just go back here. So inside the platform here, I've just a very, very simple folder. And inside of it, I've uploaded a mesh called wire shelving. And this is a very, very simple mesh. It's just a bunch of wire racks together, and there's a material applied to them. And I have two versions of it that are identical in every way right now. And what this mesh is when you import it into 3Kit, I just have a bunch of meshes here that are in different parts. And you can see here in the unoptimized original version of it, I've actually left off the quantization tab here. So for compression, I've left it off. And this would generally be automatically on when you bring something into the platform. So you don't have to do anything for this to work. But I just wanted to take a moment and show you what that would look like without it. So if you kind of take a look here, you can kind of see, well, take a look at it. This mesh is around 63 kilobytes in total. That's uncompressed. There's no quantization going on right now. And on the right side, you can see that there's quantization turned on immediately. Your 63 kilobytes went to 45 kilobytes. So that's already an instant 25% savings that you can think about without having you to do anything. If for whatever reason you can come in and turn it off, but generally we recommend that you leave it on, because what that means is when you're loading this mesh for use in your configurators, instead of loading that full 63 kilobytes, you're loading only 45 kilobytes. This is a little bit inconsistent with how complex your models are, because this is rather a shape where there's a lot of different geometry in it. You can see that there's 2.5K faces for each of the shelves, and in the whole model, there might be about 10,000 faces here. So you're going to see that 25%, and that number is a little bit varied depending on the complexity of your mesh. And I'll show you another example of where you won't get that many savings, which is in a much simpler display, much simpler mesh. So in this mesh, you can see I've got very simple geometry, square, and you can look at immediately already how many less faces there are for this. So before we were dealing with 10,000 faces, now we're looking at 387. This is a fairly optimized asset. And as you can see here, I have optimization turned off for the unoptimized one. And on the optimized one, if I do go and turn it on, there's not going to be that many savings. So you can see here before we were at 11.6 kilobytes or 11.6 thousand kilobytes. And here we're at around 10. So you're only really getting about 15 to 20% savings on this asset, but that is in part because the data is already so dense in terms of the way that you've set up this mesh. It's much simpler. There's less things that can be optimized about storing the data. All right. And you're going to find this as a recurring theme on a lot of the things that you bring into the platform. It's very customizable about the way you want to go about optimization. If you want to be more aggressive, you can do that. If you want to be less aggressive, and your customers are okay with waiting an extra 0.25, 0.1, 0.3 seconds, that's okay as well. We give you all the tooling that you're going to need to do that in the platform. Yeah, so that is quantization, and it will be applied automatically on all messages that you bring into the platform. Let me just slideshow. And the next thing that I want to talk about is the other thing that you might have seen a little bit earlier, which is the simplification tool. So this is a tool that gives you even more fine control of your meshes. So after you have got them into the platform and they've got the quantization enabled or the compression enabled, this is something similar to if you've used other tools like ZBrush, it would be ZRemesher, where this is actual retopology of the mesh. It takes some optimization algorithm and allows you to edit the vertices, edge loops of your model directly. Now, we've done it in a very streamlined manner, so anyone can go into a model and start playing around this. Those are the only properties on it. So the WebGL reduction is you'll be able to crank the slider and be able to see an immediate change in your model. However, there might be some times where it creates artifacts where that's where you might want to dial it a little bit back. But yeah, we've tried to make it as easy to use as possible so that anyone would be able to go into your models and start getting performance boost right away. And let me just take a look to show you what that looks like in platform. So same thing as we had before. I'll just go to another model here, and I'll show that one again. But I really wanted to show off how you could go about doing this and the amount of savings that you'd get. So the unoptimized, we'll just leave it as is. We don't really touch anything here. We'll leave it unquantized. So you can see the base amount would be 63,000 kilobytes. But let's start taking a look at our asset. So as you can see, we've got kind of 4 pillars here. They're mostly cylinders, and these might have a little bit problem when you optimize them if you bring it too far. And I'll show you what I mean by that. So as you can see here, we're going to just start sliding this slider around. And immediately you can see right now, I have 1.5 thousand mesh memory used right now. If I bring it down to 50% reduction, you don't really see too much of a difference in the cylinder. But we've went down from 1.5 thousand to 745. We've almost halved the amount of load that you need to. Now you can see that at the very top where it's very jagged, you can see that it's simplifying the end cap loops of this mesh. So I'll just bring it back to 100. You can see that's what the original looked like, and bring it down to 50. So you can kind of see, whoops, the amount of optimization that does happen. But you're getting, for this small detail, which you might not even see, if you're zoomed out way like here, it's not going to be a very noticeable difference for this part. Let me just bring back here, and we'll go. So let's say we're happy with 50%, or if you want to be less aggressive, let's do 60. Let's do a 60% here, and I think that'll give us fairly good results. Oops, this will go 65. Why didn't it apply? Okay, just give me one moment here. Okay, we'll keep it as 50. Okay, and onto the main majority of this mesh's memory usage. So you can see that here we have 44,000 kilobytes used for these. I think we can be a little bit aggressive, and let's try 50% as well. And that's not really something that you can see a difference in, because again, these are generally cylinders that you're not going to see too much of a big difference in, especially when you're zoomed in a reasonable amount. Maybe we can go a little further. Maybe 60%. So you can see that it's getting a little more jagged, but still you get the general shape of a cylinder, and you can kind of see it. Where you might not want to progress, and what I'd warn against, is when you're cranking this up really, really high. So let's say I was really, really aggressive and I wanted to do 85%. So now there's significant deformation of the topology. And you can kind of see here, it's no longer resembling a cylinder, more as a square. And that's because the algorithm is trying to join as many vertices as possible to give you that kind of reduction. But just as a note, we went from, let me just go here. Whoops, we went from 44,000 to 5.5 thousand. So that's a huge amount, but obviously you wouldn't want your meshes to look like this. So let's go with a maybe less aggressive target. Let's go maybe a 65% reduction. And yeah, I think that's still, maybe we could go 60 here. Yeah. So looking at these models from a reasonable distance away, you'd be hard pressed to find really any big differences between them if you're going to be viewing them. Of course, if you really, really nitpick and go into the models like this, you can see a very, very clear difference from the left side to the right side. You can see that the right side is much more defined edges. You can see that the cylinder end caps are very smooth, whereas this one, it's a little more blocky. It's more like a hexagon or an octagon rather than a 32-face cylinder. But let's call a little bit of attention to the savings that you're going to get. So as you can see in the original, we have the 63,000 full kilobytes, but on the optimized one, you're down to 12,500 kilobytes. That's almost I'd say in 75%, 80% savings in terms of reduction time. And this is, I'm going to come back to this point of, you can be aggressive as much as you want to, or you can make it a little less aggressive. But you're going to be able to take advantage of these tools in terms of simplification to customize the meshes the way you want. Another thing that I want to call out here is that this is completely non-destructive to your mesh. So if you were to make a change to your mesh here, getting back to the original is simple as putting 0 and 0 here as well on my meshes, and we have not changed the original mesh whatsoever. So if I come back to here, I'll still have quantization turned on, but I'm going to go back to that 45,000 45,500 kilobytes that I'm using originally. So there's no danger of, if I use simplification, it might mess up my mesh. It's going to retopologize and I won't be able to go back. There's none of that. You can play with it however much you want. Find a right balance for you in the meshes that you have at the correct viewing distances. Like here, if we just go back to 55 and 50 for these ones, it'll give you an immense boost in performance so that your customers aren't waiting 5-6 seconds. They're waiting closer to half a second or maybe 0.7 seconds. Yeah, that's everything that I wanted to talk about for quantization and simplification. Before I move on, I realized I didn't do this in the last session. Is there any questions? I'd like to be able to address any questions that anyone might have right now. No. Perfect. Okay. So on to the next point. So that was everything to do with meshes, but where I'd like to really emphasize some big points is on textures. Textures is going to be the bulk of size when you bring something into the platform, or for models in general. They're very, very dense, and they generally have to be brought in as maps for your materials. So this is one of the best ways to target performance on your models. When you reduce the size of your textures, you're getting a huge increase in performance, where before we were doing maybe kilobytes, 100,000 kilobytes, or that would be like 10 megabytes of data. Textures easily go to 30, 40, 50 megabytes per map, right? If you're going to import a 8K texture or a 4K texture, and that's a huge amount of data that the system has to load every time a configurator is called. So I want to talk a little bit about some of the things that we have in the platform to help you reduce that size. Yeah, so I just wanted to call out here is 4K texture is 16 times the size of a 1K texture or 1024 texture, thanks to the inverse square law. When you go up in terms of squares, it's 4 times the amount of data lost, or the 4 times amount of the data used, as opposed to if you were just doubling regularly. And fitting with the theme, I'd like to show you about what this looks like in platform and how you can take advantage of it. So let's go back to here, and I'll show you a little bit of something that I prepared. So you can see here that these are nothing special. These are just regular cubes, and what I've done is I've applied a material to them. I think you'd be very hard pressed to find any noticeable distance at a glance for these two maps, these two textures. They're just a very rough fabric with a roughness map, normal map, and albedo map on them. So very simple stuff, the material that most people would set up. And the differences between these doughs is immense. And I'll show you why that is a little bit later. But just at a glance, I think it's very difficult to see any noticeable difference in terms of quality for these two models. You'd really have to go into the details of these items to find any differences. And I'll show you why that is. So the first one, if it was a little hint, was the naming structure of these ones. So you can see here that we've got two different meshes. They're just meshes named different ways, but I've actually created 2 different materials, well, almost with identical maps of the same texture. The only difference is I've applied a automatic process that we have in the platform to rescale these textures. So you can see here, this is the first material, and this is the second material. Oh, that's interesting that it didn't load, but I can assure you that it's there. And I just want to call out the differences in these sizes. So you can see here, this was the 4K material that we were just looking at, the one that was here, or I'll pull it up. So the one that we were just looking at. And it is taking a little bit of time to load because, again, these are 4K textures. These are huge textures, like 30, 40 megabytes in textures alone. So it takes a little bit of time to load. But you can take a look here, and you'll see that this is 47.4 megabytes. This is insane compared to the scale that we were talking about before. We were talking in terms of tens of thousands of kilobytes. This is 47.4 megabytes. And on an average internet connection, let's say 10 to 20 megabytes download, I think that's a very fair assumption. That's still going to be 2.5 seconds just dedicated to textures. And that's why we've dedicated so much of this tooling to allow you to optimize them. You can see here, though, this is the same texture with mostly the same maps, but it's only 2.6 megabytes. And that's a huge amount of savings for just changing all of your materials from 4K to 1024. I just wanted to call that out, that's an immense difference in load time. And let's bring this back up to edit. I'll just show you very, very briefly the difference in perceivable load time. Half a second, almost unperceivable. But I'm going to load the same asset, and you can see how long it takes to load this in. So we're going almost like 4 or 5 seconds here, where it was like 0.2, 0.3 before on these textures. And that's almost entirely due to how big these files are. So now that we've kind of established what that is, I'd like to walk you through the simple process of applying this to your maps. Let me just open up, let's do albedo or base map, as some people would call it. So I'm just going to load these up. These are textures, and you'll see that in here. I'm just going to move this here. I'm just going to open them up so you can see here. They're actually the same texture, except I've edited one field in here. Where you can see here, we've got sizes. I'll actually move this to 4K because it was originally 4K. No, and it already jumped to 22 megabytes, 22.8 megabytes. And this is 1.3. The only difference between these two textures is that in the sizes, I've targeted 1024 by 1024 or 1K, as opposed to the 4K here. Now you can kind of see that math of, oh, I had 1.3 times 16. It works out to be about 22.8. There's some other factors at play here, but generally, if you move from 4K to 1K, you're going to get a 16 times reduction in size. And that's going to be reflected across every single map in your scene. So this is a relatively simple material that I've created. It's only got three textures using, so albedo, normal, and roughness map. But each one of them, you can see here, 6.3 kilobytes to 6.3 megabytes to 86 kilobytes, 18.2 megabytes to 1.3, and 5.5 to 1.3. Yeah, and it all culminates into a huge amount of savings for your materials with, to me, very, very little noticeable difference. Now, if you zoom in really close, you can see, yeah, there's a little bit more graininess, where as this one it might be a little clearer, but at the distances that you're going to be looking at, almost no perceivable difference. So I highly recommend, if you're looking at a ton of materials, that you take a look. Is a half reduction in size would be 4 times increase in performance, to evaluate some of the materials that you have in the platform and take a look at them, see if you can reduce some sizes here and there. And that's a good segue to the next point that I wanted to make. Sometimes it's a little bit difficult to do these en masse, where I'm dealing with two materials here. What if I wanted to do it on 100, 1,000, 10,000 materials? Well, we've included that right here in the sizes. So by default, you'll see that there's this thing called organization. And what this does is that when you upload any texture into the platform, it's going to start by default on organization. What that means is there's a global modifier applied to this, where instead of getting a value here, it's going to derive it from your organization. So just like here, how I've had it in organization, this was the 4K one, this was the 1024. Let's move this back to organization. What that actually is when you go into your performance tab, you can kind of see here, we've set some settings for you. So if you wanted to apply this en masse to all the textures in your organization, you can. So you can select here, just like how we had right here, you can select the same amount of settings. And let's say I wanted to make all the textures in my organization 1024. I'm going to hit save settings, bam, done. I've just instantly got that. If I was uploading 16K or 4K textures, I've instantly got a 16 times reduction in performance for all my texture assets. And that's a big savings. As we took a little bit earlier, instead of waiting 3 seconds, now you're waiting 0.2 seconds, 0.3 seconds for a material to load. And we can kind of come back in here and we'll see. We'll just launch this, or we'll take a look at here. So this was 4K, and let's just bring this back to organization. So it might be a little bit difficult to see the difference in quality as there's also nothing to compare to. But this now would be essentially 1024 because this is pointing to what value I want to use in the organization. And this is saying I want to use 1024 as my resolution. Yeah, it's a great way to get performance out of your assets. And again, this process is completely non-destructive. So if you brought 4K textures, 2K textures, 1024, 512 textures to the platform, you can enable this without worry that your original texture is going to be lost. It's generating a version of that texture to use that's called whenever you're going to be using that. One last note that I did want to make about this feature is that if you have a higher quality selected, so let's say I've brought in a 1K texture and I have 4K as my default. 3K will not upscale your textures for you. They're just going to be using the original. So if 3Kit finds that you have a texture that's 1024 by 1024 and you've selected 4K here, it's going to use the 1024 by 1024. It's not going to upscale your texture for you. There's many services to do that, but if you wanted to, 3K would not be doing that. Yeah, before we move on, I know I went at pretty big neck speed. Is there any questions that anyone has? Awesome. So the next part would be, let me just go back to slideshow here, would be, yeah, and these changes can be applied in bulk to all the textures of organization. And we already went through if the map that you're using is smaller than the default, it's going to use the original map. And I'll hand it back over to Pascal for AR optimization.
All right. A nice feature that we have on the platform is proxy models, is where you can have a clone of some of your model. Let's see, a sofa where in OpenGL or WebGL, you would want to have a little bit more higher quality to see of your model. And then you can also have another model where when it's loading in the AR, it would call a different model where it will be more optimized. This is where you can have a proxy model and you can guide it to where you want to load different models on the platform. And there's another thing from the simplifications that was added is there's an override basic AR where the same thing what Kelvin was mentioning. Now you can also override and you can also add an extra percentage over your to reduce and to load a little bit faster. And also it's always good to look into like the WebGL while you're applying those settings, so you can see what it's going to look like in your AR, making sure that you don't, like Kelvin was mentioning, is where you don't want to go overboard too much. It all depends. Depending of your project, depending of your models. But yeah, this is where you can have like a specific percentage for each of your AR device. Yeah, it's quite simple here on the platform, but it's helps a lot. And I think that's it.
Yep, I think that is all that we have today. I know we went pretty fast, but I left a little bit time for questions, and I guess we'll move on to the last slide of if there's any questions about anything that we covered today or any things that you want to know about. If there's any features that you're confused about that you might have seen today, yeah, this would be a great time to ask if anyone has any questions. We did a pretty good job explaining it then. always good to hear. But yeah, that is all the content that we've prepared for today. Thank you everyone so much for attending, and we'd love to see some of the stuff that you make, and we hope that you can take advantage of some of these features and get the most out of 3Kit. Thank you everyone for attending, and I hope you have a great rest of the day.